here we think it's much, much easier. Okay, lesson 2. Most of the compounds that we have tested preclinically, there is a whole legion of metastasis investigators. And metastasis is something we have to use mice for. There's no little on-the-bench assay in cell culture for metastasis. We put the cells into the mammary fat pad, because that's what you call the breast of a mouse. We grow a primary tumor, we remove it, and by then the cells have spread and we can drug dose, okay, and see what happens. The literature, I'm here to tell you that the literature is chock full of promising drugs that will prevent metastasis. But they haven't come forward, okay? It is much easier where they have tested in mice the ability of these drugs to prevent the formation of a metastasis, where they have tested it to shrink an already established metastasis, they don't work. I just showed you a slide before why they don't work. Blood supply, blah, 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 okay? So these drugs tend to work on single cells or micrometastases only. That's the rub. And I would love it to be otherwise, but that is where the preponderance of the literature. These are inhibitors to enzymes you probably aren't familiar with. SARC, focal adhesion kinases, some of the receptors tyrosine kinases. And I'm going to show you another one. Okay, and my 20 years of looking at this literature says that they could meaningfully help either prevent metastases from happening, period, or preventing more metastases from happening. Here's just some examples of what's in the literature that I'm trying to talk about. Here's one that we just published. It's an inhibitor I guarantee you haven't heard of. So this is a receptor. It's called a 7-transmembrane receptor. So if this is the cell membrane, this protein goes back and forth 7 times. It's a G protein coupled receptor that they just got the Nobel Prize for, okay, the discovery, because they're highly druggable. And this is a receptor for stuff floating around in our bloodstream in copious quantities called LPA. It's lysophosphatidic acid, and you don't need to know that. Okay? But this is the receptor. It's highly druggable, and here sits an inhibitor to it that we worked with a small company in Switzerland. And I'll just call it 0719 because I'm no good at long numbers. Now, what does this receptor do? It tends to tell cells to move. So you immediately get what we're aiming at here. It really doesn't tell cells to stop growing. It tells them to shut up, sit still. So here's the study design that we and many others with many other compounds did. Okay, I'm going to make you all investigators. You take a bunch of mice. On day 0, I put a triple-negative mouse breast cancer into the mammary fat pads of mice. It would then start growing. On day 2, we give them a day or 2 to recover from surgery. We randomize the mice to vehicle or this compound. Okay? Nope, don't need a computer for this. The primary tumor grew for 8 days. So we have 8 days of data of will this drug shrink a primary tumor. Okay? We then did the surgery, got rid of the primary tumor, kept dosing the drug till day 70. If you're a metastasis researcher, you're used to very slow experiments. And then we took a look at the metastatic burden. So, and we imaged. You'll see this in all the reports. I've got cells that glow. And you put them in, you put these mice in, and you can see the cells, and it gives you a quantitative estimate, however imperfect. This is day 10, and it's a couple of the mice, all right? And depending on blue is a little bit of cells, and red is a whole lot of cells, here are just a couple of primary tumors from the vehicle, the placebo-treated mice, and from these 0719, this receptor inhibitor-treated mice. Any difference? Mm-mm. Here's the actual data from 20 mice per arm, mean size, vehicle, and here's the 0719. Just ignore that third bar. First lesson. This is how every drug that has come down the pike has been preclinically validated. People, it's even worse than that. And believe me, at NCI, I see this all the time. You throw tumor cells sub-Q in a mouse, and you grow a primary tumor there, and you dose it with drug and ask it to slow down the growth. That's how they all came through, okay? So based on this data, this would be what we call a dead drug, okay? It didn't slow down the primary tumors. Think about how many dead drugs there are out there. Look at day 70. This is what they missed. This is what the drug development industry doesn't do, okay? And we'll talk about why. So now you're looking at widespread metastatic disease in these vehicle-treated mice, and you've got some, but a whole lot less, and this is probably a primary tumor regrowth. Mouse surgeons aren't quite as good. Okay? But you get my point. We never, ever depend on the imaging. So here are the actual counts by a pathologist when we went and sectioned. Let's see. This is the liver, and this is the lungs. So here is vehicle, and there is 0719. Here is vehicle, and there is 0719. Oh, my God. We can prevent metastasis to a good extent here. Here's what absolutely blew my mind. So we were staining these tumors. I wanted to see how, was it cytotoxic? How was this happening? So we stained, starting with those primary tumors that didn't shrink and weren't affected, for something called Ki67, and many tumors are stained for this. It's a measure of whether cells are in the cycle to keep on proliferating or not, okay? And so all the cells would have these little blue nuclei, and if they were in cell cycle to proliferate, they would be green. They would be stained with Ki67. So you can see a lawn of blue in this section of a primary tumor with a lot of green. And the same here, no difference, okay? And here's the actual data, control, treated. Look what happened in the liver and the lungs. So this is a liver metastasis in the white dashed area. You can see the lawn of blue tumor cells, and those that are trying to grow, Ki67 positive, proliferate, are green. Here is the largest liver mets we could find in these experiments. You see the blue cells, but blessed few of them are green. These cells have come out of the cell cycle and are basically what we call dormant.